about the sound. Today we will discuss some more topics related with sound. We will discuss some numerical problems, then about the reflection and absorption of sound. Then we will discuss about the echo, then what is sonar, and how can we make a soundproof box. So one by one we shall start. First of all, we shall start with few numerical problems. Then we will proceed. Here in your book, when you will see there are few solved numericals are given. So just I am reading the problems. Then we shall try to solve it. The first question is a wave pulse on a string moves a distance of 10 meter in 0.5 seconds. Find the speed of the pulse. A wave pulse on a string moves a distance of 10 meter in 0.5 seconds. Find the speed of what we have given: distance 10 meter, time 0.5 seconds, and what we have to find: speed. Speed we have to find. So apply the formula. What is the formula? Speed is equal to distance upon time. So what is the value of distance? 10 meter. And what is the value of time? 0.5 seconds. So please calculate it. 10. We should try to remove the decimal. Multiply by 10 in numerator as well as denominator 0.5. So what will get? 10 into 10, 100, and here 0.5 into 5, 10, 20. So final answer will be 20 meter per second. Distance is given 10 meter per second, time is given 0.5 second, and we have to find that speed. So distance upon time, 10 upon 0.5, multiply this value by 10, here 10, so you will get 20 meter per second. This is the first solution of first numerical. Okay, please look at it carefully, then only you will understand about the numerical problems. Okay. Second question is a boy standing 660 meter away from the source of sound hears. A boy is standing 660 meter, means distance is 660 meter. Okay, standing 660 meter from the source of sound. Given the speed of sound is 337 meter. Speed of sound is already given 330 meter per second. Calculate the time after which the boy hears the sound. Calculate the time. Boy means after the when sound is a boy standing 660 meter away from the source of sound. This source of sound releasing from the source at 330 meter per second speed. So what is the time to reach to this distance? So what we shall apply: speed is equal to distance upon time. Distance 660 meter. Okay, and speed we can apply this. Time will go here, and this speed will come in denominator. So 330. 0 cancel 0. 30. 3 to 660. Means in 2 seconds. The sound can be listened in 2 seconds. So formula is equal to time is equal to distance upon speed. 0 cancel 0. Finally we will see in 2 seconds. So we can listen that noise after 2 seconds. This is the numerical number second. Question number 3. So please revise it carefully. Both the numericals. It will directly come in your examination. So revise it properly. Question number 3. A sound is heard 4 seconds later than the lightning is seen in the sky on a rainy day. Given speed of sound is 346 meter per second. Speed is 3. We can write speed as 346 meter per second, and the time is 4 seconds. And what we have to find? Distance. So speed is equal to distance upon time. Distance is equal to speed into time. 346 into 4. 4 6 are 4, 4, 2, 8, 30. So 1, 3, 4, 8 meter will be the distance. A sound is here 4 seconds later than lightning is seen in the sky. On a rainy day, given the speed of sound, the distance we have to find time and speed is given, distance we have to find 1348 meter or 1.384. 1384 can be divided by 1000 to convert it to kilometers, so we will get 1.384 kilometer. This is the answer of the third. So by this we can find the different types of numerical. Okay, so please revise it. Then only you understand about the numerical problems. Simply you have to apply the formula of speed and speed time distance. Okay, here reflection of sound, reflection and absorption of sound. So students, what is the difference between the reflection and absorption? Absorb is when we throw anything on any surface, if it is not reflected, means it is absorbed by that surface. Suppose we are throwing this marble on this surface, if it is absorbed by this surface, means it is not reflected from here. And if we are throwing this and it is bouncing back, means it is reflected. So reflection and absorption of sound. If sound is reflected, means bouncing back of sound in the same medium, then it is related with reflection of sound. Bouncing back, we are throwing here and it is coming back, so we can say it is a reflection. If it will be absorbed, then we can say it is an absorption of sound. Okay, so the bouncing back of sound in same medium is called reflection of sound. There are laws of reflection: incident sound wave, reflected sound wave, and normal, all like the same. Incident sound wave, reflected sound wave, and normal, all should be like the same plane. Okay, this is the first law. Second law: angle of incident is equal to the angle of reflection sound. Angle of incident sound and angle of reflected sound wave always should be same. Okay, the first is incident sound wave, reflected sound wave, and normal always should be like the same plane. And the second law is angle of incidence is equal to angle of reflection. Okay, so this is the reflection and absorption of sound. There are different types of surfaces available. On some places sound will be absorbed, and in some places sound will be reflected. So this is the law of reflection of sound. The second term is echo. What is echo of sound? Okay, when we are saying something to someone, so if suppose this is a person, he is saying something, so there are two sounds. First one is direct sound. If I am saying something, it is a direct sound. Okay, this is the first. And the second sound which we are hearing after some time, approximately 0.1 second, 1/10th time, we are able to listen that sound. That is an echo of sound. Okay, if we are saying something to someone, so whatever I am saying, it is a direct sound. And after few seconds is after 0.1 second, one more sound we are able to listen. That is a indirect sound, and we can say that is a echo. Indirect sound, that is coming from a source, that is a echo of sound. There are different conditions for echo. We shall try to understand that condition. Direct sound should be louder. If the direct sound is louder, then only we can listen echo. Other things doesn't matter. Direct sound should be louder. Second, there should be reflecting surface. Okay, already I discussed here. There are two types of surfaces. First one is reflecting, and second one is having property or absorption. If there is a reflecting surface, then only we can, means it should be hard surface, metallic surface. Okay, brick surface. Then only we can listen this echo of sound. And the last one is distance. We shall calculate this distance here, but one thing we have to remember here: at least 0.1 second time lapse rate is required, and distance 17 meter. If a room is having area in which distance is 70 meter, then only we can listen echo of sound. Okay, so these are the major conditions required to listen echo of sound. First one is direct sound should be loud. Second is it should have reflecting surface, and the last one is distance approximately 70 meters. So we can calculate this distance. Speed is equal to distance upon time. Distance is equal to speed into time. We know that the speed is approximately 332 meters per second, and what we said for echo of sound, approximately 1/10 or 0.1 second is required. Okay, and for this distance, if this is the d distance, so sound will go here, and after the reflection it will come here. Okay, so a plus b, total distance will be 2a. So we'll put here 2a. So 16.6 meter, the correct answer is 16.6 meter minimum distance is required for the echo of sound. 32 meter speed and 1/10 the approx time. Okay, so this is all about echo of sound. Only one thing we have to remember: echo of sound is produced in case or where the surface is reflecting. Okay, sonar is sound navigation and ranging. It is a device using the ships for the navigation. It is used to detect the obstacles coming in the sea that are like depth. It can be calculate the depth of the sea. It can calculate or it can detect the presence of iceberg or different type of obstacle or different water animals by this sound navigation and ranging. Sonar is a device which is used by the persons who are traveling in the ships. So it is a device used in the ships to detect the obstacles which are coming in the sea, like depth of the sea, presence of the iceberg, different types of animal. So here there is a system in which there are two systematic objects are fitted: reflectors, reflecting surface, and transmitted pulse. So here, when the waves will come, strike with the obstacle, and it will be transmitted on the transmitting surface. This is the transmitter and this is the receiver. Okay? So we can say the reflecting pulse will go and absorb by this reflecting surface. Okay? So this is the concept of sonar. Okay? What is the good and bad reflector? This is the last topic of your syllabus. Good and bad reflector. So try to understand about good and bad reflector. Good and bad reflector of sound. Good reflector means when sound strikes with metal or any brick object or any hard surface, it will easily reflected from that surface. Okay. Suppose when this is a well finished reflecting surface, when we are hitting on this surface, the sound is reflected easily. But suppose we have any bad reflecting surface. Suppose this is a we can say small cloth. When we are hitting here or when sound is striking on the surface, sound is not reflecting. So we can say it is a bad reflector or good absorber. It is a bad reflector or good absorber of sound. So there we can say bad reflector or good absorber, and another one is this is a good reflector of sound. So the objects that can easily reflect the sound are the example of good reflector, like all the metals, brick walls, and the sound the object that absorbs sound or does not reflect the sound are the bad reflector. Okay. So in picture halls, bad reflectors are required. In picture hall, auditoriums, bad reflectors are required or good absorbers are required. That's why you can see the curtains are kept besides all the wall to absorb the sound. Okay. You cannot observe echo in picture halls. Okay. And last is the soundproof box. Last is the soundproof box. Soundproof box is a small project that you can make. Okay. In which it should have all the wall. This whole object should be made of wood. Okay. If you make this object by the wood, so we can control the sound. Okay. So soundproof box mainly is a device which does not allow enter any sound, or sound cannot enter in the soundproof box, or the inside sound cannot go outside. So it we cannot say 100%, but 90-95% it absorbs sides. Sound cannot go outside, and outside sound cannot come inside. Okay, so we can use different thermocols on floor. We can use woods and mat on the surface and wooden walls to make this soundproof box. Soundproof box is a device which can control 100% sound inside the box. So this is all about this chapter. This is the reflection of sound. Reflection means bouncing back of light, bouncing back of sound in the same medium. Then we have discussed the law. This is the speed of sound. Okay, echo means indirect sound we are listening just after the saying something by the direct sound. Okay, we can calculate this distance. This is a sound navigation and rendering device, and last one is a soundproof box. So this is enough for this chapter. Please revise carefully. Whenever you feel any problem, you can ask me. Okay. So thank you for today. Now please complete your exercise. Then I will send the exercise. Okay. Thank you for today. We will meet in the next class.